Question 8, figure 8.1 shows a circuit and the lamp has a resistance of 3 ohm. This is the lamp and I said it's R1. Okay, and line XY represents a uniform resistance wire of resistance 6 ohms. So this is XY, which is length 2 meters and has a resistance 6 ohm. And I said its symbol is R3. And there's one more resistance is connected in series, which it means end to end. It has 2 ohm, which is symboled by R2. So these R1 and R2 and R3, these I wrote them to make it simple for me to calculate the reading on a meter. Okay, the question has 2 marks. So firstly, I can use the voltage and these resistors to get the current or the reading of the ammeter here. So firstly, R total for the equivalent resistance equals to the summation of these 3 resistors. They already connected in series. As I said, if series means end to end. So R1 plus R2 plus R3. So equals to the 3 for the lamp and the R2 for the resistor, the second one, and R3 for the resistance, the last one, XY, the resistance wire. So 3 plus 2 plus 6, it means 11 ohm. Okay, so now we have the value of the total resistance. So there's only one way, or the losses step to get or to calculate the total electric current passing through the wire. It's I equals, according to Ohm's law, V divided by R. The V for the total voltage, which comes from the main power supply, it's 12 volts divided by the total resistance, which is 11. 12 divided by 11 is 1.1. The SI unit, which is the ampere. So you get here 2 marks. In part B, figure 8.2 shows the circuit with a different connection to the resistance wire and an added resistor. The length XY of the whole resistance wire is 2 meters. The contact is made at Q, where the distance XQ is 0.6 meters. Now the examiner is asking to calculate the resistance of the circuit, means the total resistance or the equivalent resistance. These are the terminologies the examiner is using them to express for calculating the total resistance. So the question has 4 marks. Okay, how can I get the full 4 marks? Okay, firstly, I'm going to start from the complicated part, which is calculating the resistance, which is XQ, because it's a small section out of the total resistance of the XY. Okay. As you know, the resistance is directly proportional to the length. It means that if you think about the 0.6 now, it's a small section out of the total resistance XY, the whole wire. And I know the value of the XY from the previous one. It was 6 meters, 6 Newton, 6 ohm, I'm sorry. So we have the total length and the equivalent resistance for the XY, and we have the length XQ, which is 0.60, but we don't know the value of the resistance itself of the XQ. Okay, so I think if we use the formula of the ratio, like R for XQ for the small section, and as a function of the length, because they are directly proportional, divided by the RXY for the whole wire or resistance wire, and XY for the distance itself, which is 2 meters. Just make substitution, RXQ, which is unknown, divided by 6 ohm from where that we get from the previous section, it's already given, and xq, which is this distance, which is 0.60 divided by the xy, which is 2 meter. Here as shown, it's 2 meter. Okay, we use the cross multiplication. Our xq equal 0.60 times 6 divided by 2 equals 1.8 ohm. Now there is no problem for the arc xq. We notice that the xq is connected in parallel with the 1.5 ohm. So in parallel, it means that I have to use one formula to simplify these two resistors together. So I know if you multiply them and you divide it by the summation of these two resistors, this is the formula. So they are parallel for both resistors, xq and the 1.5 ohm. So it means that the 1.5, and I know the value of its xq from the previous one, it's 1.8 divided by 1.5 plus 1.8. It gave us finally 0.82 ohms. Okay, Mr. Is that the last step? No. What else you have to, this is the total, which is the total parallel resistors, must be added to the 2 ohm and to the 3 ohm for the lamp, because all of them, they are connected now, it's end to end, and they are in series. So the total resistance, so this is the last step, R for the lamp plus R for resistor plus R for the parallel. R for the lamp is 3, R for resistor is 2, and 0.82, which is the parallel one. So once we add them, it gives us finally 5.82 ohm. So now we get 4 marks.